All right, so can everybody hear me okay? Looks like the people here in the room can, hopefully people on the stream can as well, and obviously, hopefully our next presenter can hear me, because that would be really unfortunate if he can't. So, coming up next here, we're going to have a talk from Vince Weaver, who's submitted some pretty cool Apple II stuff to us the past few years. Tonight he's going to be talking about his demake of a 2000s Flash game that kind of pretended to be a retro game, but really isn't, and making it into an actual retro game. So without further ado, Vince, are you ready?
Yep, sure.
Cool.
Okay, so hello, yeah, I'm Vince Weaver. I'm an associate professor at University of Maine, and always like to throw a picture of Maine up here, just try people come here, always open for, collaborations, grad students and all that. So as a background, Demakes. Demakes are when you take a more modern game and try to make it work on retro hardware, and I sort of a hobby of doing this, and I've been mostly doing sort of 1990s-esque games, so like Duke Nukem 1, Monkey Island, Final Fantasy, Portal, and Kerbal Space Program, Out of This World, games like that. And most famously, I did work on the Myst. I did a whole entire demake of the entire game Myst and fitted it on 3 Apple II floppies. Not talking much about that today, but I gave a talk this past summer at Mysterium, the Myst conference, and you can go see that if you want to, but I did some work on that. And Fame was excited about that. I actually have the world record speedrun for the game, so feel free to challenge it. So I did all these things in Apple II's low resolution graphics mode, which is a low res 40 by 48 graphics mode, and everyone hates it. Apparently, I'm the only person in the world who likes low res graphics. And people ask, why not do high res? Why not do Apple II also supports a 280 by 192.6 color mode. And so for Myst, this is sort of impractical. High res is 8 times bigger. It's 8 kilobytes instead of 1 kilobytes. And so as you can see, you can run through some tools and get some decent looking graphics. But the, it's expensive being 8 times bigger. And if you only have 48K of RAM, this is a huge chunk of RAM, huge amount of disk space. Instead of taking 3 disks, it would take, 24 disks. And you can compress these things, but rarely better than 50%. And on the Apple II, in theory, you can have up to 14 drives. You wouldn't actually want to do that, though. So what did they do in the 1980s? How could you have games? People actually made elaborate high-res games and most of them didn't require you to have like 50-plus disks. And so they did, instead of having bitmap graphics, they would have do things like this. This is Wizard and Princess, a Sierra game, where it draw line segments, and then it would do a flood fill. And so as you can see, it would gradually fill it in, and then you get a little text mode at the bottom. That's sort of the common thing you do. So the question was, could you do this with Myst too? And so it began as a size exercise for the Apple II robot. And once you got a little out of control, you could actually do things with some primitives. It wasn't just line drawing symbols, it was actually sort of vector primitives, like boxes and circles and triangles and stuff like that. And the whole game is super constant. And it takes forever to walk this out by hand. And as a little demo, I made a little bit of this in some sarcastic text parsing. And doing this little project, I didn't have another game that is sort of Sierra-like and has sarcastic text into it. And that's the game Peasant's Quest from 2002. So this was a Flash game, just on the webpage. And in it, it's sort of a spoof on the King and similar games from the 1980s. You play a peasant, brother Dash, seeking revenge on the dragon Trogdor, burning your Dash, and you have to seek revenge. This is part of homestarrunner.com. If you've ever been there, they had a really popular website with Flash cartoons dating back to the 2000s. They had a long-running series of Strong Bad, a character checking his emails, and Dragon was the most famous one, possibly, and introduced Trogdor the Dragon. And this was the game. They eventually turned it into a game. It's a little HGR thing back in the day. I was around for it, but at the time I was running Linux on a G3 iBook PowerPC, and they didn't actually have a Flash player plugin, so I missed out on the whole era of people making Flash games and Flash animations and all that personally. Anyways, a spoof of the King's Quest from 1984, and you can see it's very similar. There actually was a version of King's Quest for the Apple IIe. It took 128K of RAM. It was double high res, but you can see screenshots from it there, and it fit on 3 discs. So, running a game like this on an Apple II isn't sort of that unusual. So the team over there at HomestarRunner, they have a sort of fake video game company that makes all their games called Videlectrix. And the funny thing is, all the pictures they have on them, there's a very thinly disguised Apple II they use for this, though they cheated a bit sometimes. This is actually a monochrome screen, but you can see the superimposed, color picture on it, though. And other things, when you load the game, the Flash game, it actually plays some Apple II floppy drive noises. And it was funny, when I posted the first demo of this, some people were shocked that it was a real thing. It wasn't just something they were making up for comic effect, but the Apple II really does make this horrible clicking noise when you first turn on your computer and such. And the Strong Bad character also, in theory, uses that Apple II. So they have a working Apple II there, and still post things on Twitter sometimes. You can tell he's using an Apple II. So I thought it'd be interesting to take the game and actually port it to an actual Apple II. So some quick background, if you're not familiar with the Apple II, the original Apple II was released in 1977. Apple II Plus came in 79, which is a little bit better features. But it has a 1 megahertz 6502. The original only had 4K of RAM, but eventually 48K, 64, and beyond. The original one was discrete 7400 series logic, and it had a cassette tape for loading programs. Later, they came up with disk drives that hold 140K. No fancy graphics, no fancy sound. It's just a bit bang the speaker. You actually had a cycle count to play music on it. It had a 40 by 24 text mode, a 40 by 48 15 color low res graphics mode, 140 or 280. It's sort of complicated. We'll get to it in a minute. 6 color high res, and with basic and ROM. They had later models like the 2E and 2C, so why not target that? I always like targeting the older machines just because I like them better. But you can get machines with 120K of RAMs and double high-res graphics, which is better graphics, a 6.5 CO2, more powerful processor. The problem is when you use the newer machines, you start getting unfavorable comparisons with like Commodore 64 people saying, oh, our machine's so much better. But if you go with the original Apple II Plus, 77, 79, then the comparisons are with like the PET and the VIC-20, and so it's easier to make your stuff sound better. And there was an Apple II GS for graphics and sound. It had megabytes of RAM. It had a 16-bit processor, and that's more almost sort of the Amiga equivalent of the Apple II line. And so it always seems like overkill for these types of things, and I usually stick with the older models. So developing it, how do I develop these things? I base them in gameplay in this case, from the actual website. I didn't decompile or reverse engineer the Flash. I just look at the pictures, like play through the game, take screenshots. There's a wiki. They have a very elaborate wiki for their the cartoons on their website, and people actually had most of the text broken out already, which helped a lot. There's still some things that are open questions. It's hard to figure out from gameplay, like the exact music notes used in the music or the odds of characters appearing and stuff like that. So I did this in Apple II high-res mode, and if you've ever used high-res on the Apple II, it is horrible. You might say it's 8K frame buffer at 280 by 192 by 6 colors. Doesn't sound too bad. There's 2 pages, 2000 and 4000 and hex. That's all you get, though. There's none of the fancy stuff you find other 8-bit machines. There's no hardware scrolling. There's no sprites. There's no fancy coppers or stuff like that. What you really get is just this frame buffer, and it's not even a good frame buffer. If you look down here, it's a little hard to see, but it's interleaved. Like the first line on the screen is at one address, but then you skip ahead like a kilobyte, and then skip ahead a kilobyte the whole way to the end of the 8K, and then you start over again, and not exactly the same spot. And Steve Wozniak, he did this. He saved chips, and I think he got the DRAM refresh for free by doing this, but it's really a nightmare to program. So one nice thing about it, and people always comment on this, is if you access memory linearly, it gives this weird blinds effect, and everyone thinks you're doing a fancy demo scene sort of wipe, but actually it's actually harder to do a regular screen update than it is to actually have a transition like that. The pixel layout, the pane too, there's 7 pixels per byte, and colors in group of 2, so you really get 3.5 color pixels per byte. And it's backwards. The least significant bit is first, and the top bit of the byte will shift things a half pixel, and that has something to do with the colors we'll see in a minute. But it does mean, like odd and even bytes, your bits are all set by 1, 2, so the colors are shifted on odd and even columns, which is a pain. The colors are all NTSC artifact colors. You get 6 colors because there's 2 blacks and 2 whites. And this is the thing that he figured out by flipping the top bit. You can flip from the palette from the green purple one to the orange blue one. And you get other weird effects too. If you try to draw a single pixel at the 280 resolution, you actually, depending on odd or even color column, it'll give you a different color. So you actually, that's why you have that thing's 2 pixels wide. If you have 2 colors touching, if two ones in binary touching, you get a white. If two zeros, you get a black. So at the edges of colors meeting, you get weird conflicts. So doing sprites is a challenge. There's no hardware sprite. You do it all in software. And to have a sprite in an arbitrary position on the screen, you have to do a lot of shifting and masking, or else have these big pre-computed sprite tables. For this game, I cheated. And as long as you have only the sprite, the 7 pixels wide and always a multiple of 7, you can just write a byte, and it's simpler. But it means you have to fit things in that. And the other thing, because the odd-even thing, if you have a color sprite, not black and white, the color will actually change. If you're odd or even columns, you either have to account for that or else shift things yourself. Transparency is a pain too. There's no real way to do transparency. Usually you have to have like a special mask sprite to mask out the colors that you don't want, and then the actual sprite you want to OR in, so it gets to be a little complicated. Because of this, you get lots of color artifacts, almost like not quite ZX Spectrum type color clash, but almost. So the different palettes can't touch. So you see in this picture here, green and orange can't actually touch in a 3.5 pixel wide radius. So you get sort of blocky things of green and orange touch. The two colors of whites aren't equivalent. One goes with one set, one with the other. So you see here, this white is the green and purple white. If you try to touch the blue, you get little purple artifacts. Even colors that should go together, like green and purple, on the edges, you get the problem I said, the zeros and ones next to each other. So you get little white and black artifacts at the edge of things like that. So it's a little hard to get right. Pixel art is troublesome too. You're trying to get the pixel artist and say, hey, do Apple II. And you're like, sure, we'll do it. And you try to give them the list of all these things. And, they just go nuts. Like, you might draw it in your pixel editor and it looks great. But you have to do this funny thing. You'll notice the blue and orange are actually half a pixel off. And so things are to the side here. So if you draw things sort of normally, the pixels might be over here. If you try to draw like the cross originally on this guy's shirt, this would actually bleed in and the arm would sort of blend into it and stuff like that. So you have to watch out for this kind of thing. Same thing here. If you try to draw this, what looks like a very nice, sprite, green and orange can't be together. So you end up, you can't have them at the same time. Things that are only like one color pixel wide, like this purple here, ends up doing the black and white thing and things like that. So you have to be very clever and careful when you're moving your colors when you're trying to do things like this. And one other interesting old style thing that turned up in this that I hadn't even seen in person before is the original Apple II had a lot of quirks in the graphics. And here, if you draw white right at the edge of the screen on one side, it'll wrap around and give you a magenta line on the other side. And this is just sort of a glitch in the hardware. And you actually usually can't draw magenta in this graphics mode. So maybe a clever Demosplash programmer could somehow do something clever with that. But it's just a little interesting thing came up while doing this. Background, so you walk around in the game, you can walk behind things. And the old Sierra games had this too. AGI is sort of the Sierra way of doing this, where you have sort of, they called them 3D backgrounds, just meant you could walk behind objects and all that. And so it'd be nice in the game, and so I had to figure out how to do this. But having a whole other 8K of data to have the boundaries and collision and the distances, there just wasn't enough RAM for that. So how could you do this? But we weren't using the low-res screen, so I repurposed the low-res screen for that. So drawing the low-res screen, you draw the black outlines and the different colors from 1 to 15, say how far away in the Z distance you are. And then when it draws the sprite of the peasant here, it checks his feet. And if you're behind, the certain boundary, it draws and gives you that depth thing too. And so the only downside of this is it's sort of blocky. It's in a 4x7 groups of pixels, but the effect actually works okay. One other thing, copying that in, you might think it's easy, but Apple II has something called screen holes on low res. It's a 40x24 screen, 960 bytes. So you actually have 64 bytes left over scattered throughout. And you might be like, well, can't you just overwrite them? It turns out since the original Apple II only had 4K of RAM, they actually gave those a scratch pad RAM to the expansion cards. So if you have any expansion cards, if you just like blindly overwrite them, you can actually crash the system and all that. So you have to be careful. So in this case, we decompressed the picture somewhere else and copied it in carefully. As an aside, my low-res games, you might say how they play in a monochrome monitor, and it turns out, unfortunately, the low-res graphics don't look very well. This example I chose here is not really the best. It actually doesn't look too bad in low-res, but on an actual low-res screen, on a monochrome screen, it doesn't look that great. The nice thing is this game, high-res games in the Apple II, even when you do them in monochrome, they actually look a lot better and a lot playable, which is important. Back in the day, my filling in Apple II, but we had a monochrome screen. Drawing high-res text for a game like this can be a challenge. Unlike some 8-bit machines, you can't just print text to the high-res screen and have it work. You can actually split the screen and have the bottom 4 lines be text for free, but you can't draw that text, arbitrarily on the screen. So to have a game like this, you have to write your own high-res drawing routines. It ends up just being sort of a bunch of 5x8 sprites that you draw on the screen. And my first attempt at doing it, everything is backwards because you might remember I said it's least significant bit first. Unless you remember to account for that, then everything's backwards and all that. And I reused the Apple II font just because, I hate the font. Some text issues. The descender. So if you have like a lowercase letter like lowercase g here, you see it blends into capital N because there's just not enough room between them. And this is actual program on actual Apple IIe when they introduced lowercase letters, text mode. You might say you can insert an extra line, you can, but then you can fit fewer rows in the screen. So I haven't decided exactly what I'm going to do about that yet. And it's harder to see here, but because of the way the Apple II is, when you draw, thin white text, you get color fringing, and so your text looks green and purple or orange and blue, and that's just an artifact of the way the NTSC color works on the Apple II. So to draw the messages, we draw a rectangle, and the rectangle code I reused from the high-res Myst I just did, and it saves the background to the other graphics page, so you can see it in this example. And it's sort of a waste of space, but it's a lot faster than if I tried decompressing the background again, but it turns out it's a little slow and noticeable. And so you might say, are you wasting the rest of the other page here? Couldn't you store data here? And it looks like you could, like a nice big chunk of RAM. The problem is, remember, it's interlaced. So this isn't contiguous in memory. This is scattered all over. So it's really hard to reuse the memory there. So Dialog, the game has a lot of talking, about 40K of text or so. In a modern game, that would be nothing. But these days, not these days, but on the Apple II, you have 64K of RAM. So, that's a big chunk of RAM. So you might say, well, how did they fit it in the old days? So you can look at old games like Zork text games where they did some fancy stuff. Zork used Zscaler where they took 3 characters and fit them in 2 bytes. And they had special shift characters to switch between upper and lowercase and numbers and things like that, and some clever things. That's a little beyond what I want to do for this. So in the end, I just tried some other things. So I just used plain compression. I used the LZSA algorithm and decompressed the compressed text to a chunk of memory. And so each group of levels it decompresses, and so there's room for 8 kilobytes. So I have to divide the game into chunks where you don't have more than 8K of text. It's a tight fit. I was adding more to one of the levels and went over the boundaries. I'm going to do some alternate stuff to try to make it fit some more. One thing you can do is word substitution, like have a dictionary and look it up. So we have 7-bit ASCII, so the high bit we could use to look up in a dictionary. So I actually was doing some stuff where I ran all the text through some word distribution to see what it is. And it's sort of interesting. It looks a lot like standard English word distribution until you get to the bottom here and then you start getting words like trogdor and peasant and baby, and you realize that it's what game you're going on by the time it gets to there. Command parsing, so you type commands here. So you walk around a bit and you type commands to interact with the environment. And so simple verb-noun parsing tend not to work. So you scan, the first word you type has to be a verb, like look at the well or look at the tree and stuff like that. And then it's a list of nouns, and it searches for those, and then it goes and then gets those 2 and you can look things up. And currently supports up to 76 verbs. You can see 113 nouns. It just does a simple linear search, which seems to be fast enough, and a jump table, and has a fallback if you ask for something that's not known. It falls back to give a response. It saves some room. Instead of using null terminated strings, it uses high bit terminated strings, which is common on Apple II and on 6502 chips because it's easy to check the high bit. So the last character in a verb or noun you're checking just has the high bit set to say it's the end. That's a problem, though. If we actually run up over 127 nouns, then this won't work anymore. But hopefully we have all the nouns we're going to need. That well level is a tricky one because it's the only place where you need more than 2 nouns. So you can actually have to distinguish between put pebbles in well versus put pebbles in a bucket versus put baby in the well or other things like that. So you have a special case just for this level to reparse for another noun so you can handle things like that. It also, in this level, it's tricky. You can either look at the well or look in the well. And so we have to have a case for that. And I just cheated by making in well treat it as a noun and have it search for that and handle that. So moving around, the Apple II keyboard, the Apple II and II Plus didn't have up and down arrows. And I'm trying to target so this can run on a high-end II Plus. So in the end, what happened is I have it so you can walk around with WASD keys like a modern game, but you have to press return, the equivalent of enter key to enter commands. And it seems to more or less work. Apple II keyboard makes games a pain too in general cases because walking around like it doesn't have a key up detection. It's just an ASCII keyboard. So you press over and you let go of it. It only has the key press events, no key release events. The game is a spoof of the Sierra games though that were made for Apple II though. So a lot of the controls actually map well to that because they had to handle Apple IIs as well. So the controls actually aren't too much of a problem compared to other things like Myst and Out of This World and Duke Nukem and all that, where it was a huge pain trying to get the keyboard. Random numbers. The game has a few random numbers going on. The Apple II built-in random number stuff is pretty awful, so I use a linear feedback shift register for that. Music, it plays some music. So if you have a Mockingboard card, like this right here, I have a music that can play tracked PT3, AY3, 910 music. Demosplash 2019, I gave a talk about that. And so it can play the theme and all that. If you have no Mockingboard, it can use Electric Duet, which is a music player by Paul Lutis, who was a famous Apple II person from back in the day. He actually famously made this code that played 2-channel sound out the speaker. He locked himself in a cabin off the grid in Oregon for a long period of time and wrote this code and all that. The thing is, it takes all the CPU to do this. It's more or less raw CPU power cycle counting. So for the intro, when it plays the music, if you're doing that, you can't get the animated fire burning on the peasant's head. Like, it has to skip that part because it's using all the CPU for that. I can still flip between the dragon scene, though, because that's done using page flipping back and forth. Sound effects of the game are just mostly musical notes. And so while the Apple II can't do much while those are playing, for the short little bursts of sound effects, it's okay to stop and, play them. So speech, when you get towards the end of the game, the Trogdor the Dragon will come and talk to you. And they actually designed it so that it's using the software Automatic Mouth, or SAM, which was a program back in the day where it would do speech synthesis on an old 8-bit computer. So the Apple II can do it. You have to get one of these boards, which are a little hard to find, and it also takes 9K of RAM to hold the speech info, and unfortunately, there's just not that much room for that in the game. You can bypass having the board and play through the speaker, but it sounds really awful. You can barely hear what's going on. For the game, I actually did add speech support, but it uses the SSI 263 chip. If you look back at my Mockingboard, there's empty sockets there. You can get these speech synthesis chips and put them on it and use the same interfaces through the Mockingboard and have speech synthesis. So I have that working. It works great in the emulator. I tried finding the chips to actually try it in real life, but they're expensive and really hard to find, and they go for a lot on eBay, and they don't show up that often. So I haven't actually been able to test it on real hardware. So disk, fitting a game like this on a disk can be a bit of a challenge. The disks hold 140K, and currently it can fit on 2 disks. It's likely going to end up being 3 in the end. So there's a lot of disk swapping, though I might be able to add support for 2 drives, so you can put 1 disk in each, and then it would involve less swapping. And that was a sort of common configuration for games back in the day. So there's some disk swapping, and for some people, it brings back nostalgia, like, oh, isn't this fun swapping disks? But I have to tell you, it gets old really quickly. Even worse if it's not a floppy drive, but if you have an SD card or USB-based disk emulator and you have to switch between things, it can be a huge pain. Also, you can upload games like to Internet Archive, and they'll emulate them in your web browser, which is great, but the problem is they only support 1 disk, and so if you try to play like this game on it, you can play through till the first time you need to switch disks, and then, you're out of luck. So it's hard. I'm going to need to optimize the game to try to make it so you have the least number of floppy disk switches while you're playing, because, it just sort of brings you out of the game, and it's sort of a pain. And one way of doing it is putting all the intro and booting and ending stuff on 1 disk and have all the gameplay in the second. And the problem is that runs into the problem when you try to have people play it online and you can't switch disks, because then you can't play the game at all. You can just do the intro. So it's one of those interesting things you have to worry about. So the disk layout, it uses some really fast disk accesses that Cucumber, an famous Apple II hacker, invented. I gave a whole talk about this at Demosplash 2020. So it's the same stuff that the Myst Demake uses. And so it's really fast, even for the Apple II. And if you're comparing against the Commodore's, the Commodore Drive, it's way, way faster than that. So there's no file system at all. It just has a bootloader that loads up. And then you just have your chunks of your game there linearly on the disk, and it's starting and ending tracks and sectors, and it can load them. And I'm trying to make a good diagram for this, but this is the layout of the 2 disks currently. The various levels, there are about 5 tracks, which is about 20 kilobytes. And the various other parts. And then 1 square here is 1 kilobyte. So you can get a rough idea of how big various things are. And there's things like the game over screen and the map and various mini games and all that. And the boot's right here and the save games. And beginning in disk 2 has a single little boot sector. It just loads up and says, hey, this is not the boot disk. Put disk 1 in. Load and save games. So it does support load and save games. Currently it has 3 slots. And the game save state is really small, like 22 bytes. I should probably consolidate this to 1, because what happens when it first does, it reads all 3 to find your current location and prints it, and then it goes back when you load it and loads it again. But I could just put this all in 1 file and save a bit of a trouble. The original game actually has an autosave as you play. Every time you get a point, it saves. So that seems like it might be a good idea, but the problem is the save game's in disc 1, you might be playing in disc 2, and if every time you got a point, you had to swap discs, it's a pain. But it might be possible, I was thinking maybe to have like a RAM-based autosave, where it sort of autosaves the RAM, and you lose it if you reboot, but it might be enough that in case you make a mistake and have to go back while you're playing, it might be workable. So the game, I originally tried to get it to fit in a 48K Apple II, and it's just not going to fit. So right now we're using the 16K expansion. So the original Apple II Plus has something called the language card. It looked like this. That gives you a total of 64K in the system. The Apple IIe and newer had this sort of built in, so you had 64K for free. And so this plugs into the slot. And to get the RAM timings, you actually had to pop out one of the RAM chips on the device and plug it in, so we got the timings. And then pop the chip you popped out, you put right here, and then here's the extra 16K here. And one hazard is when you're using this, the way it gives you the extra RAM, it bank switches. So you have to swap out the ROMs, and it swaps in the RAM. And that means if you're using firmware routines for doing the graphics, either you have to constantly switch between them or else just get rid of them. In the end, I just got rid of the firmware routines. It's okay. It's actually faster not to use them and all. And it worked out okay. So all the text parsing, the inventory, music, things like that, I'm using the language card for. And this language card here, when I bought it, I paid about $16 for it for 16K of RAM, and that was a good deal considering what they cost back in the day. But if you work out the math, it actually works out that I paid $1 million per gigabyte for RAM for this board, which is, just ridiculous when you think about it. So the RAM map in the system, on a 6502, the bottom is a 0 page, and you put, small commonly accessed variables there, and there's a stack. You get one 256-byte pages stack, and that's all you get. And so the some lookup tables for the disk and interrupt handlers are down here. The low-res screen, which we're using for the 3D stuff, and the boot and some common routines go here. Page 1 is the backing store for the graphics, and page 2, the actual graphics are used here. And so, and then the 20K for each level data goes here. Some lookup tables for the graphics, and then the language card here, the inventory and the dialog for the current level, and the common string parser and all that. And so RAM's pretty tight. There's not much extra room. So you might be wondering how I developed it. So the graphics, I used the tool, the GIMP, to use it, and I have some custom conversion tools to take a PNG and convert it to Apple II format. To get the graphics, I took screenshots in the browser and scaled it to a 290 by 192 grid, and then put either grids of 2 or 7 to find out what the graphics would look like. Programming, I had to do it in Linux. I use a 6502 assembly language I just use Nano as an editor, which everyone always is down on me for, but I like using it. And the CA65 assembler, which is part of the CC65 compiler project, but I use that to cross-assemble things and develop that way in a Linux box. And to test it, I run it in the WinApple emulator on Linux using the Wine emulator to emulate Windows. There's a bunch of emulation happening in a row here. And it was time to actually try it in real hardware. I copied to a USB or SD card to test on the actual machines. So the current status of the game, all the locations and data are there in the backgrounds. I'm still hooking up the plot, so you can only play so much of the plot right now. I was hoping to have more of it done by now. I was actually working on some demos for Demosplash, and it sort of took away from the time of it. But you can get up to 50 points and up to 6 endings. And soon you should be able to play straight through. The one thing that's missing are the animations, so you'll be able to play through it almost like a text adventure. But the one problem I'm having is getting all the animations to fit and play while you're doing it. So you can walk through the game and get a walkthrough from somewhere and play through it, but it's going to be a little bit before I get all the animations hooked up. But I do plan to try to get it all working. So that's a big challenge, these animations. They're large in size. Like this boat animation here is almost 4K uncompressed. And so the question is, how do I fit it in memory and on disk? You don't want to be switching floppies around just whenever an animation plays and all that. And you can compress it, but then you have to find a place to compress it too. So it's an interesting challenge trying to get this all to fit. Other challenges getting the game to work, the map. This is one of these games where the map fills itself in as you walk around and visit. And so while that should be possible to do, I just haven't got around to doing it. But you can pick up the map and view the map. Another challenge, part of the game, way through the game, it starts to rain. And so how do you do that? I'm sure there's like some sort of demo scene type thing I can do with like, a rain effect to do this. But, it's one of these things that's sort of simple to do maybe in a Flash game, but on an actual hardware, it gets a little tricky. Another thing, there's a part of the game where it turns to night for a while. And so how do you do this? I mean, do I have to redraw backgrounds for all these scenes during the night? Can you do it algorithmically? You know, if this was a VGA DOS game, it'd be easy enough. You could very easily do this by just doing a palette swap and just drawing your colors right and very simply. But, you know, Apple II doesn't have palettes. And so this is where I might need a whole other disk. You know, you might just need to redraw the backgrounds with like a darker pattern of colors. There's an archery minigame in the game, and so this is going to be interesting too, especially with the wind and aiming. It's got lots of these large sprites, and you know it's going to be a challenge trying to get that to fit. So it should be doable. You see the graphics look okay. You notice that, you know, 7-pixel wide graphics with not much transparency, so I'm not doing anything fancy here. I was making it, you know, a little simpler on the Apple II side there. There's another minigame where you have to climb a cliff, and this one should be more straightforward. And you see some of the challenge here is getting the colors going. On Apple II, if you draw pink and green next to each other, and a lot of monitors, especially monitor and CRTs with comb filters, it sort of looks like a gray, even though it's purple and green. And you can do a lot of dithering to try to help with the lack of colors, you know, only 6 colors, but it's still a bit of a challenge. Another challenge, the end credits. Actually, the end credits all implemented, and it actually looks fairly nice. The thing is, in the actual Flash game, they do the cinematic pan where they're panning across the scenes from earlier. And I mean, I'm sure, again, there's a demo scene way of doing that. It just doesn't seem worth the trouble. So you don't get fancy panning on your end credits. So you might ask, you know, you're re-implementing the game that these people made. You know, are they excited about it? And so they actually are aware of it. But I've only contacted them through their Twitter account, which is in character with their strong bad character. So the interactions can sometimes be a bit obscure. So I mean, I'm pretty sure they like it, but some of the responses are a little hard to parse. But they seem excited about it. They actually run an interesting YouTube channel right now where they're featuring a YouTube channel where they're actually playing old DOS games and stuff like that. And sort of coincidentally, they were joking about someone should make a CGA DOS version of the game right around the time I start working on the Apple II version. So is there a market for Apple II games like this, you might ask? And so other platforms like Commodore 64, people make games, people buy them. There's actually like a thriving industry there. Apple II, unfortunately, not so much. The Apple II people tend to be really in it for nostalgia. They like playing, you know, Wavy Navy and Lode Runner for like the 1000th time, and it's hard to get them interested in new games. The 8-Bit guy on YouTube, he released a game called Attack the Pesky Robots for Commodore 64, and it has an Apple II port, as you can see here. I got an autographed copy because my PT3 code player that I mentioned, music player I mentioned before, he actually uses it for the game. So I'm there in the credits. But he made it and he tried selling it, and like I know the demand from the Apple II people was not what he had hoped. But you can actually do and release new games, and even on Steam. Nox Archaeist is a game, sort of like Ultima-like game for the Apple II that just got released last year after a long wait. And you can buy it for a box release with like little feelies and floppies in it, but they actually sell it in Steam. You get it in Steam, and it's bundled with an emulator. So when you run it on Steam, it'll fire up an Apple II emulator, and you actually can play it. So who knows? Maybe Peasant's Quest, if we get it going, you could do something like that, which might be interesting. So yeah, that's just my talk on, you know, taking a game like this and how you can try to fit it on an older system. And you know, this one is more interesting than most because, you know, it was sort of jokingly as if it was on an older system to begin with. So actually trying to do it is like an interesting, you know, kind of thing I like doing. So I'll be glad to take any comments or questions, or feel free to email me. I don't know if we have the setup here for taking questions live, but I'll be glad to answer any questions. And you can get play the original game, and you can also get download my version and try it out too. And the source code is up on GitHub. So.
The audience has a question they'd like to ask. And I had Skype on mute, so Vince probably just saw me holding a microphone and couldn't hear anything. So we do, in fact, have a setup for taking questions. If anybody here in the local audience would like to ask a question, just come on up to the stage and we'll let you ask your question. If anybody on the chat would like to ask a question, just so if you're in Discord, in the event chat, you can ask your question there. If you're on Twitch or on our IRC channel, any questions you ask there will also go to the Discord, and I will see them on stage, and I'll go ahead and ask Vince. I have one question for Vince, not really directly related to the topic topic of his talk just because I'm curious that I'll go ahead and ask to give people some time. And that is, I see you have some interesting looking numerals up above the normal Arabic numerals there. What exactly are those?
So those are the numbers from, if you ever played the game Riven, like the sequel to Myst. They have a base 5 numbering system in that game. And so when I gave a talk for Mysterium, I went through a lot of trouble to get LaTeX to be able to talk base 5 numerals, and I think it looks cool enough. I've been including it in my talks.
All right, thanks. Well, thus far, I'm not seeing any questions here. I see a couple of people typing in Discord, though, so I'll give them just a second.
Okay.
It was someone thanking me for asking the question I just asked.
Okay.
Well, thanks so much for giving us another interesting talk this year, Vince. And, we hope you can come see us in person sometime when this whole pandemic thing is finally over.
Yeah, I hope so too. Thanks.
All right. Well, enjoy the rest of your evening.